When we picture the cloud, we usually imagine endless, cavernous warehouses of blinking lights. It looks like a singular, massive alien brain operating in the desert. But a data center is a hive of millions of individual, identical pieces. If we strip away the rest of the rack, we are left with a 1U, or one rack unit server. This flat piece of metal is the atomic unit of the internet. Every email you send, movie you stream, and credit card transaction you make routes through one of these specific, unglamorous pieces of hardware. Yet it looks nothing like the desktop computer sitting in your office. The vast architecture of the internet starts here, within the specific anatomy of this single brick. Pop the lid off a server chassis, and the engineering is strictly utilitarian. There is zero wasted space. Everything is tightly packed and built for relentless processing. Right in the center sit the CPUs, the brains executing massive mathematical loads. Flanking them are banks of ECC RAM, providing immediate high-speed data access. At the very front are the storage arrays, the long-term filing cabinets holding actual databases, websites, and media. When you click a link, that request hits the server. Data is pulled from the storage, loaded into the RAM, processed by the CPU, and sent back out to the internet. This entire sequence of events occurs in microscopic milliseconds. While a server shares the same fundamental parts as a home computer, its internal layout is optimized for one thing: absolute raw data throughput. The outer shell and life support systems of a server are engineered for the same relentless labor as the chips inside. These machines are headless. They lack graphics cards, monitor ports, or sound cards because they never need to interface with a human user. Keeping these chips from melting requires extreme thermal dynamics. High RPM fans pull cold air through the front and expel hot air out the back continuously. Since failure is anticipated, if one power supply fails, a second instantly takes the full load. Even the storage drives up front are hot swappable. A technician can pull out a dead hard drive and replace it without powering down. The physical design is entirely dictated by survival. If an individual part dies, the machine's labor doesn't stop for a single second. The server's survival-focused design makes sense only once slotted back into the rack. That flat shape was engineered solely to maximize vertical stacking density, allowing dozens of identical units to share the same space. This redundancy scales up to the network level. If this entire server suffers a catastrophic failure, another unit in the rack immediately picks up its exact workload. Rows upon rows of these racks stretch across the data center floor, forming a massive distributed network. Millions of these highly specialized, tireless physical workhorses hum in unison to build the physical architecture of the modern digital world.